Let's walk through an example of how to find the cutoff for a given confidence interval. So for the 95% confidence interval, we can use about 2 standard errors. Although, as we'll see at the end of the video, we don't actually want to rely on that exact 2 standard error rule. But what about for other cutoffs? We can use the normal calculator to find the cutoff for any given level of confidence that we are interested in. This tells us how many standard errors away from the proportion to reach. So as you saw on the previous page, we could reach 1, 2, or 3 standard errors away to be more or less confident in our answer. Here we can find the breaks even between those exact thresholds. Whatever we calculate as that distance, that calculated standard error is what we're going to multiply by to get the margin of error, which is how far away we actually need to reach. This is going to mean that our confidence interval is just our p hat plus or minus our margin of error. Now let's walk through an exact example so we can see how that works in principle. So let's return to our example of rolling 100 dice and getting 12 sixes. Our p hat is 12 out of 100, which means, as on the previous pages, we can calculate our standard error as square root of pq over n, which gives us 12 over 100 times 88 over 100 divided by 100, which gives us an answer of 0.0325. For this, we want to find a 90% confidence interval. So we need to find a 90% critical value. So to do this, we're going to go over to StatCrunch. So open up StatCrunch, go to the normal calculator, Stat, Calculators, Normal. Now we want to find the cutoff where the last 5% of data are. The last 5% of data, because if we want the middle 90%, that means 10% needs to be in the tails. Because the normal distribution is symmetrical, we're going to split that 10% up and put half in each end. So we want to find out where that last half goes. So we're going to call this the 95, or 0.95. What you'll see is we're cutting off where the last 5% of the area under this curve is. We're getting this value of 1.6448536. If you were to plug this into a calculator or anything, you would want to use as many of these decimal places as you can. Now, as an important note, if we put in the bottom 5%, so where is the first 5%, we're going to get the exact same number, just with a minus sign in front of it. So because we're going to do plus and minus in a moment, we only need one or the others of these. So our critical value, that z star, is going to be 1.64. Again, if you're doing these calculations for an exam, you'd want to use as many decimal places as you can. So our margin of error, as we said before, is z star times our calculated standard error. This means that we take 1.64, what we just found with the normal calculator, multiply it by 0.0325, our standard error calculated up here, and we get 0.0535. Now that means that we need to reach that distance in order to calculate our confidence interval. We are 90% confident that our true population proportion lies within 0.0535 of 12 100ths. So to calculate the confidence interval, we do exactly that. 0.12 plus or minus 0.0535. Now note this means add it and subtract it. We're going to get 2 different answers for that. So we are 90% confident that the true population proportion is somewhere between 0.0665 and 0.1735. This is how you work through a problem to see how to calculate the confidence interval. Now as a final note here while I have you, if we were to put in 0.975, so cut off the last 2.5%, this would mean that the middle 95% are in between. Okay, 2.5% in the upper tail, 2.5% in the lower tail, gives us 5%. What's left is the middle 95. And click compute, you will notice that this answer here is not exactly 2. The 68, 95, 99.7 rule that we've used up until this point is just a shorthand. It is just a shortcut that gets us close enough to the answer. For exams and quizzes, make sure that you use this number. I do not expect you to memorize it. I expect you to remember how to go find it here in StatCrunch by doing exactly this. Or finding this video and watching it again while you're taking the quiz.